Good evening everyone, and welcome to the monthly Beyond Zero Emissions discussion group. Firstly, we would like to acknowledge that we're meeting on the land of the Kulin Nations and pay our respects to their elders, past and present. We'd like to thank the Melbourne Energy Institute at the University of Melbourne for this great venue. For those of you that haven't been to one of our discussion groups before, BZE is a climate solutions think tank and research organisation. Our goal is to transform Australia from a 19th century fossil fuel-based economy to a 21st century renewable-powered clean tech economy. Our projects include Zero Carbon Australia research, Repower Australia talks, Zero Carbon communities, and media work, education programs, and much more. We're always looking for more volunteers, so come and talk to us afterwards if you'd like to get involved. The discussion group is a forum for climate change solutions with presentations by experts in their field and is generally held on the first Monday of every month. Tonight we welcome Peter Fadeyev, Nissan's Product Communications Manager for the Asia-Oceania Region. Nissan is the world's largest supplier of electric vehicles, with more than 270,000 sold globally since 2010. Would you please welcome Peter?
Thank you. My name's Pete Fadeyev, and I look after product communications for Nissan in this part of the world. Nissan, of course, is a Japanese automaker. It's headquartered in Yokohama in Japan, and my regional office is based in Bangkok, but I'm lucky to be based in Melbourne, and I'm thrilled to be here this evening to talk to a group of engaged, high involvement, high knowledge people about electric cars. So this is a refreshing, rare opportunity for me, so thank you. And especially thank you to Pete and Demiwa for the opportunity to speak today. I'm very grateful. In planning this, I could keep you here for about 4 hours discussing electric vehicles, where we've come from, where we're going, what we have. And I settled on the idea of trying to address these 6 key topics. Basically who we are, which I think is very important. I'll cover that very quickly because it provides a lot of context as to how we can achieve what we achieve, what we build, where we work, and when we started this, and it wasn't necessarily with the outgoing model of the Nissan LEAF, which started sales in 2010. And I want to give you a glimpse of the future. And I was just talking earlier about the competitiveness of the automotive industry, and I'd love to show you more. But for the benefit of the recording, it's a highly competitive industry, and we can't share an awful lot, but I'll give you a few hints as to where it's going, and it's very encouraging. Now, as I mentioned, Nissan, of course, is a Japanese car maker, and it's been around for a very long time. We built our first car in 1933, but it's part of a very big alliance with Renault that was established in 1999. Some of you will know this, some of you, it will be a discovery, but we have an equity tie-up with French car maker Renault, and it was established some years ago, and we've since joined a couple of major partners along the way. Now that upper right-hand graph does look a bit complex, but you can see that Nissan owns 15% of Renault, and Renault owns about 43.5% of Nissan. And along the way, we gathered 2 other brands, Daimler and Mitsubishi. Now this is an alliance. It's important to stress the point. It was never a merger, and it's one of the reasons why it's been so successful. Nissan and Renault bring to the table the best bits of what they can do and what they know, and they share them. And it produces these great production and R&D synergies that give rise to models like the cars I'm going to show you. Last October, we acquired 34% of Mitsubishi Motors Corporation, and that made Nissan Mitsubishi's largest shareholder. And the reason for doing that is simply scale and to get greater efficiencies in production for both companies. So it's another mutually beneficial, synergy-based operation heading our way. But about 7 years ago, we entered into a partnership that at first glance might look a bit unique, and it's with Daimler, a German automaker. It's the parent company of Mercedes-Benz. And Mercedes-Benz, of course, as a brand needs no introduction to any of you. But it's a high-tech company that's very skilled in certain areas. But naturally, it probably wants things that an automaker like Nissan has, and of course Nissan wants certain things that Mercedes-Benz has. So we, again, established an equity-based partnership, and we've now got 13 projects running worldwide that include everything from vehicle development, R&D and technology, through to vehicle assembly in places like Latin America. So we're rather big as a result. So around about the 94 million cars sold last year around the world, just under 10 million were from our alliance, so about 1 in 9. It's a very large operation, and it's growing. So in terms of global rankings, just to give you a quick context, in terms of the top automakers around the world, the Renault-Nissan alliance is about 4th. And that number of 9.96 million is expected to change a little bit over the course of this year. We're expecting a bit more growth because of the alliance acquisition with Mitsubishi and some other growth factors. And as you can see, our manufacturing footprint is very large. We basically build and develop components and cars in all major centres around the world, including Australia, and I'll get to that shortly. So let's funnel down a little bit and talk about some of the electric vehicles that the Alliance makes. And I think it's fair to say that a number of people, rightly, have the view that there's only a handful of electric cars you can buy around the world today from only a select number of automakers, but that's not necessarily true. There's quite a few, and I'll show you. Just in the 3 Alliance brands we have of Renault, Nissan and Mitsubishi, you can see here are 9 examples, and there are more. And you can see from our sister company Renault, there of course is the Zoe, the Twizy, 2 very popular, very fun to drive if you've never driven one, electric cars, and a couple of light commercial vehicles in the form of the Kangoo ZE and the Master, which is going into production. Nissan of course has the LEAF, which is a small car, which is technically categorised as called a C segment car, but we call it small car in Australia, about the size of a Nissan Pulsar. And if you've been following the press, you'll know that the original generation car in blue has just been succeeded by the one on top of it, the white car, which is coming to Australia, good news, next year. We also make a light commercial vehicle called the ENV200, and it's sold in Japan and Europe. And our partners at Mitsubishi do have a couple of their own EVs, most notably, of course, the IMx, which you'll know from some years ago. So in all, we're rather successful. When you put it all together, since 2010, when the first of those EVs went on sale globally, in 2010, we've sold over 424,000 units, and it's growing. And it's growing because of a couple of main reasons. One is the uptake of electric vehicles, and secondly, because of the number of models we're bringing to market. So that number will grow. We're expecting it to grow in a slightly more compound fashion. So let's funnel down into Nissan electric vehicles, the company I represent. There's quite a bit to be said here. So for the remaining 15 odd minutes, I'll try and cram in as much interesting information as I can. And please feel free to put up your hands and ask any questions along the way. But before I do, can I get a show of hands? Who owns an EV? Who's driven an EV? Okay. Who wants to own an EV? There's no lucky door prizes today, I'm afraid. They're a fantastic experience, you'd have to agree, when you've got zero RPM, you've got maximum torque. It's a great experience to see this whoosh of acceleration in this chamber of silence. You would all agree if you've driven one? Yeah, fabulous. We started EVs quite some time ago. This is the first electric car we built, and it's in 1947. In peacetime Japan, after the war, petrol was in extremely short supply, so some resourceful people established a company and built cars that were powered by lead-acid batteries, and this is the first of them, and it's called the Tama. It's named after the town in which it was built. And although the performance characteristics are rather modest, 35k an hour top speed, 60k range, 3.3 kilowatts, it worked, and it was used mainly as taxis and as utilitarian vehicles in that period in history.
What country?
Japan. I've seen one example. It's tremendous. It's one of the most beautifully designed cars with so much thought into its exterior styling. It's utterly gorgeous to look at, and it's very big. And you can see the batteries actually roll out on both sides of the car in a sort of swap scheme that might be familiar to EV fans. So you could replace those lead-acid batteries when they were depleted with ones that had been freshly charged. So what's always new isn't always new when you think about it. But we kept going with EV development. So after the Tama, through the 80s and 90s, a lot of R&D work went on behind the scenes, and some of it did break through the surface. And here are some examples. The Prairie EV from 1996, that car, there were only 30 units made, and it was used in basically fleet operations. Only a handful were in circulation, had a modest range and a modest top speed, but it was a great test bed for the succession of cars to come, such as the Ultra, which was an MPV, a multi-purpose vehicle for families. Around 200 units of those were built, and they were used in car share schemes in California and in Yokohama. And as much as they were never groundbreaking cars in terms of commercial uptake, they did pave the way for a lot of things to come, especially the development of lithium-ion batteries as applied to cars. The Hypermini EV, I don't know if anyone's seen that car previously. If you're a Nissan fan, you will have seen it popped up in a lot of social and digital media. And the Pivo 2 concept car As odd as that looks, and often concept cars take design to extremes, brought a lot of ideas, such as the fact the wheels have in-wheel motors that spin 90 degrees, so the car's highly manoeuvrable, and the cabin actually spins. So as much as there's a little bit of cartoonishness about that car, keep in mind a lot of these things that are developed do come to market in time. The EV developments that automakers undertake, and I can only speak for Nissan here of course, tend to work to a plan, and this is our blueprint. It looks like a standard PowerPoint slide, but there's a lot of thinking behind it, and it was established based on a lot of that knowledge and experience that came from places like the development of the Tama in 1947, as well as every other development the company has worked on. And there are many I could take you through, from variable compression engines to turbochargers that do strange and wonderful things. But they're all honed into something that is designed to take the buying community, consumers and societies into a place that is essential, that is valuable. And that's in terms of how cars are driven by people, how they're going to be powered, and how they integrate beyond themselves. And this is the set of guiding principles that our company uses for all critical product decisions. So for example, intelligent power is the centrepiece of our electrification strategy. And you'll see in time that the Nissan LEAF isn't the only model that will have EV power applied to it. We've got commercial vehicles, there are more things coming in the future. And this is essential because you can't just build for the market today because of the lead times involved in car making. Are many of you familiar with the automaking process? In really simple, rough terms, and of course you'll be familiar with this, it takes between 4 and 7 years to develop a new car, and it can cost upwards of $1 billion US. So the investments are very significant, and the need to succeed is always there. And you can see why the innovation steps in the auto industry are often incremental, because you can't afford to take a major risk. But you do need guiding principles. So we're considering how cars will be driven, powered and integrated in society in terms of our next 10, 20, 30, 40 years. And there are many examples, I've only put a few on there. Intelligent driving looks at how cars will be driven, and we released last year a thing called ProPilot. It's our autonomous drive system. Anyone familiar with ProPilot? If you're familiar with ProPilot, you're probably familiar with the levels of autonomy a car can have, 1 through 5. This is level 1 autonomy. The car can actually drive itself in a highway lane, it can keep in its lane, it can brake, and it can accelerate and correct the steering for you without you touching the wheel. ProPilot 2 will incorporate technology that will let you change lanes on a motorway. And ProPilot 3 in time will let you actually go around corners. And then beyond that, you've got effectively robotised cars that can drive themselves without you having your hands on the wheel or your eyes on the road. And these technologies, I promise you, are real, and they're on their way. So this is what we build in the Nissan stable. Of course, we have the Nissan LEAF and the ENV200. And the Nissan LEAF, of course, was on sale globally from 2010, officially in Australia from 2012. And a number of people, and it came up in conversation before tonight, was, wow, are they bringing back the Nissan LEAF? Well, the truth is the Nissan LEAF never left. We simply ran out of stock. And by the time we ran out of stock, the desire to replenish was there, but because it's such a niche car, and I'll show you how niche very shortly, niche in Australia that is, the decision was taken to wait for the all-new model to come, which was unveiled in Japan only in September and went on sale last month in Japan. And we've done rather well, because the LEAF alone is the world's best-selling electric car. We've now sold just over 291,000 examples around the world. It's sold in almost 50 markets, and it's won, and I can tell you, a staggering 111 awards. Cars of any kind, whether they're supercars or hypercars or four-wheel drives, do not win that many awards in one life cycle. That's quite extraordinary. And what's more, it took out 3 of the biggest: World Car of the Year, Japan Car of the Year, and Europe Car of the Year. And if you think of the proliferation of models available, and as far as paradigm shifts go, the LEAF has really delivered. And it's been used by families, singles, organisations, businesses, councils such as Sydney City Council bought 10 of them some years ago, and they're used as taxis all around the world. They are a fabulous application. If you ever get a chance to drive an EV, don't pass it. So let's go down to the local situation and our EVs in Australia, and of course that's confined to the Nissan LEAF. As I mentioned, the new model is coming in 2018, and we can't wait for it to get here. And if you're an EV fan, make sure you have a drive of this car. But I'll take you through some of the key details about the first gen LEAF, because they are in the second-hand market, and if you are in the market for an EV, I encourage you to consider one as a second-hand car. They're fabulous if you've never driven one. But here are the essential details. When it launched in mid-2012, it went on sale for $51,500, which is quite a high price for a car that's about the size of a Nissan Pulsar, which had a comparable price of about $21,000 drive away. It points to the fact that EVs are, in simple terms, relatively expensive to develop and to build, as of today, but that is changing over time. One of the most important parts of the LEAF is the fact that it has a dedicated EV platform. If you're a car enthusiast or you read the motoring press, you'll hear about platforms, and it's often simplified as the basis on which a car is built. And you'll see platforms often get reused in cars. Importantly for the LEAF, it's a dedicated EV platform, so there's no technical constraints around trying to fit electric motors and batteries into cars that were never designed for them. So the car is optimised to have, for example, its battery system in its floor, a low centre of gravity. It produces fabulous handling and even better packaging for such a small car. The driving range, depending on conditions, was around 170 kilometres. It was powered by an 80 kilowatt, 280 newton metre electric motor. If you're not into cars, a 280 newton metres of torque corresponds to about a mid-sized petrol V6. And you'll know if you're into cars, you can't get a V6 engine for a car this size unless you buy a Golf VR6. But so the amount of power and the amount of torque it delivers is fabulous for a car of this size. And of course, it was front-wheel drive. It had a host of technologies in it. And if you buy one second-hand, you'll get to enjoy them. Regenerative braking, where when you're decelerating, the electric motor will operate as a generator and produce more power to store in the battery. It has a car wings function, which lets you remotely control the charging of the car through your smartphone. You can turn on the air conditioning via the smartphone that you have on a very hot day. It's a very clever little car. And it's 100% battery EV, and it's 5-star safety rated. There are hundreds of reasons to buy this car, and I don't need to convince any of you. But I'll show you some numbers very shortly. Recharging is very simple with the car. There's standard recharging, fast, and of course slower recharging. And here are the key details. When you buy the car, you can purchase a home or an office recharger to go with it. Many of these prices vary from around $1,300 to $1,500 for a 7 kilowatt recharger, with about $800 for installation, depending on the company. It takes about 7 hours to recharge using a Type 1 plug. But quick charging, of course, is the best way to do it if you're a busy person or you're on the run. Quick chargers are typically capacitors and take around 30 to 20 minutes to recharge from alert to about 80%. And you'll find places such as Japan or North America or Europe have many of these across their landscape. And that's something that we would love to see grow in Australia. And of course, the car comes with its own connection, so if you have a 15 amp socket, you can slow charge it anywhere. In terms of cost of operating, if you compare this car, what would you say, for example, right now is peak electricity cost per kilowatt hour about 25 cents, 28 cents? Would that be about right? What would you call it?
34.
About 34 at the moment? Yeah. Okay. So based on that, roughly, one charge of this from alert to about 100% of battery capacity would put you about $9.50, thereabouts, about $9. If you compare that to, say, a car of this size, C segment, small, 4-cylinder engine, has a range of about 700 kilometres, which is very generous for a very efficient version of one of these cars. 50-litre petrol tank at about $1.30, that would take you about $63, $65 to fill it up. You're looking at around about 9 to 10 cents a kilometre travelled in a petrol-powered hatchback. Fair to say? In a LEAF, you're looking at around about 4.5 cents, so it's about half the price. So the efficiency just speaks for itself, doesn't it? It's a fabulous solution. And in time, you'll see, despite the growing costs of power, absolutely, that these things will only become better, because it's not just regulation from governments, it's the intense competition that the automotive industry has hardwired into it that will drive car makers to make them more efficient and high performing. Here's the most telling slide. So, we launched the car in Australia in 2012. Officially in 2012, because in 2011 we started participation in the electric vehicle trial with Victoria. But first customer sales occurred around July 2012. So in that entire period, we sold a grand total of 636 Nissan LEAF. In that time, 6.7 million new cars were sold in Australia. It's quite a difference, isn't it? It's a great opportunity. So I don't know if you've ever had Heath Walker talk to you from Tesla. I'm sure Heath won't tell you what Tesla sells because they've got a policy of not sharing their sales numbers. But the opportunity inside Australia, and I'm sure Heath would agree when I say this, is tremendous. Even though that is such a modest number across a period of 6 years, when cars of that size in C segment in Australia would comprise around 19-20% of all sales. Every year about 1.1 million cars, new cars will go on Australian roads. About 200,000 of those will be small hatchbacks. And you can see on average about 100 of those would have been a Nissan LEAF. The opportunity is certainly there and there's a bit of work to do. And one of the biggest things we've noticed around the world for the 291,000 odd that we've seen sold, in major places like Europe, Japan and North America, where the majority of our EVs are sold, whether it's LEAF or any other model, is they have one thing we don't have. And that is a kickstart in the form of government-led consumer incentives. Everywhere they exist, EVs take off. It's that simple. So if there's anyone in the audience tonight who's from either a state or a federal government department, I'd love you to take my details and I'd love to talk to you because there's a lot we would love to show you. It works, we can show you in many parts of the world. Does that figure surprise you when you see that? Did you expect more LEAF to be on the road? The car industry, as much as it's measured in months and in single years for sales performance, is a long game. As I mentioned, the lead times to develop a car are 4 to 7, sometimes longer. We developed a variable compression 4-cylinder engine that will go on sale next year. It took 19 years to develop to get it to production stage. The investments are very long term. So as much as 636 is a very modest number, the company remains undaunted and will keep making its way, taking all the right steps. We just love to see that kickstart because we know it would work. There is an interesting twist in this story. There is an Australian connection to the EVs that we build, and that is a number of their components are made in Australia. I brought an example along. I'll hand it around. I just ask that you be careful. It's not that heavy, but it might have some sharp edges, so please don't hurt yourself when you pick it up. This is a water jacket, thanks Pete, from the Nissan LEAF electric motor. We've been making these in Dandenong South for some years. Our casting plant called Nissan Casting Australia has been in operation for 35 years. I think in the press, the story of manufacturing is often told from a funereal angle, but we've been quietly thriving in the background, building components and exporting them around the world. We build about 2.3 million components a year. They're all 100% export. We make around 40 odd different driveline components and 4 separate EV motor components. And I could spend 2 hours talking to you about that, and I could spend 3 hours in the factory showing it to you. It is fascinating. That component right there is effectively, except for some machining, is as cast. And that component, along with these other 4, meet up with other components made in Japan, and they have to meet up perfectly. And by perfectly, I'm talking 10 to 15 microns. So they come out of the die with an accuracy of less than the diameter of a human hair, and that's what that part is. And the grooves inside it, when it gets to you, you'll see is where the water runs through it to keep the motor cool. The quality of this work is fascinating. It's best summarised as it is Formula 1 level quality in mass production, and it's made in Australia. And I'd love you to know that because it's something the company is very proud of. Some of these components are actually exclusive to Nissan Casting Australia. They're not made anywhere else in the world. Because if you're familiar with metal casting, if you're saying to fine arts and bronze casting and sculpture, it is something of a black art. It's not something that you can just establish with $1 billion in the middle of nowhere and hire people. It takes generations to learn how to do it. Many of our staff who make these components have been with us for 35, 40 years, and they are utterly geniuses at managing porosity and quality and strength in that material. It's brilliant. We're very proud of it. Don't cut yourself. And every part we make has a little kangaroo stamped in there or embossed in there as part of the casting. And you'll see on the part going past as well.
Can I ask what's it made of? What kind of alloy is it?
It's secondary aluminium. It's got a little bit more carbon than a primary aluminium would, just because we need it for the actual durability and rigidity of the part. We buy our ingots locally from overseas, and we remelt parts that go through quality control. So it's a very efficient process. We recently installed a new tower melt furnace, which will give significant cost savings over the next 5 years and reduce its carbon output by about 42%. It's quite significant. And if any of you would like to come to Nissan Casting Australia, my details will be on the last slide when I bring it up. Take a photograph, stay in touch, we'll organise a tour. We'd love to have you through. Now this is the new Nissan LEAF, and it's coming next year, in case you're all wondering. Unveiled in September at at a special event. First drive was last month at the Tokyo Motor Show. You can read about this on a variety of motoring outlets online or in magazines, and you can judge for yourself, but the commentary on the car is very, very strong. This car will expand our footprint for EV sales around the world. As I mentioned, the first Nissan LEAF was sold in around 49 markets. We will go beyond 60 with this car. And it will be here next year, as I mentioned. It's a dedicated EV platformed car. It is not a converted internal combustion car made to work like an EV, and that's critical. And as you can see from the shaded numbers in the brackets, the performance of the car steps up significantly in terms of power, in terms of its torque, in terms of its cruising range. And that's a Japanese standard range. The NEDC cycle is around 380 kilometres. It depends how you measure it. But if you compare it to the Generation 1 LEAF of around 170 k's, this is a significant step up. Recharging times are expected to be about the same, and you can see with those final 4 bullet points, the car will get a variety of new technologies, including some of our autonomous drive technology under ProPilot.
You don't mention the price.
What's that?
Didn't have the price of it.
Price hasn't been announced yet.
What's the price been announced in Japan?
What's that?
What is the price in Japan?
I'll have to get that for you.
What is the slide, mate? Item 3, E-pedal, what is that?
E-pedal lets you drive the car just using the accelerator pedal in high traffic. So, for example, if you're in stop-start but you don't want to get out of the traffic but you want to go to your destination, if you're in a city, for example, just use the accelerator pedal and it will decelerate you to a stop. So it takes the fatigue out of going between 2 pedals. As small as that is, if you do it every day for an hour a day, you can just tire you. And it's a simple innovation that makes driving a little bit easier.
Is the E-pedal variable? The key is it? Or?
There are different settings inside the car that can give parameter adjustments, but it's basically fixed. And again, it's 100% battery EV that's rechargeable. Here's a couple of technologies I'll share with you that have been in development for some time. This is the most recent of the two. The next one I'll show you is actually in production as of late last year, and it's expanding. This first one is a solid-oxide fuel cell development that we unveiled in the middle of last year. And it's intended for parts of North America and South America where ethanol-based fuels are widespread. And you can see the challenge of getting an EV uptake in such a heavily infrastructured market can be a bit difficult. But this technology builds a bridge to that. As you can see from the pictogram at the bottom, in the 30-litre tank, you just fill it with ethanol. And then it goes to a reformer which converts it to hydrogen, which passes it through some cathodes and anodes in a fuel cell stack, which generates the electricity that goes into the battery that feeds the electric motor that drives the car. It's a very elegant and simple but brilliant solution that lets people in, say, South America use the fuel they've always used, but apply it to a battery electric vehicle. It's got a huge range of around 600 kilometres. It's front-wheel drive, and you can see this technology being applied in a variety of different car types. So you get clean motoring without the need to move away from an existing infrastructure.
How big is the thing that does it compared to, say, a car engine?
It's a very good question. I've only seen some photographs in a laboratory of that on an actual test rig. I'd say it's roughly around the size of a 3-cylinder motor. It's not that big. It's not that big. It's quite efficient for space, and for the performance it delivers, it's rather good. And you can get the idea that this has been in development for quite some time. And before you would reveal such a technology, before you announce that this will probably go into production around 2020, that it's had a long lead time to get this far, and part of that would be in its packaging to keep it as small as possible.
So where does it go?
Not revealed yet. Not revealed yet.
And can you charge the battery directly?
Absolutely. And the batteries will be typically placed in the floor of the car for safety and for centre of gravity and for packaging.
What comes out of the tailpipe? I'm assuming water and maybe CO2.
Yes, a little bit of CO2, not a lot. Some of the footage we've seen of the car in test where they interview engineers talks about tree planting schemes. So I think to offset that would be one of the intentions that would go with the car, but that would be a market-specific initiative to do that.
Is less CO2 than an internal combustion engine?
They don't give a lot of numbers at this stage, publicly at least, but I would say yes, a lot less, absolutely. So watch this space. It just shows you the magnitude of investments and the push that is going on with one car company and Nissan. You can imagine what others are doing in the background as well, because everyone's approaching this zero emission solution from different angles with a variety of parallel projects, because everybody knows where the end game will ultimately be, but it's very difficult to forecast what it will look like at that destination. So along the way, as a commercial enterprise, you've got to stay strong and stay hedged, and that's why you're seeing the proliferation of hybrid technologies, for example. But we're all moving towards a very similar solution. Another one of these is called e-Power. Now this was only released overseas in October last year, and it's a series hybrid technology that is a little bit different to the hybrid type of car that you're familiar with. This is a battery electric car. That car you see there is called the Nissan Note. It's a little bit smaller than a Nissan LEAF, but it's very comfortable. It's not sold in Australia, it's sold in Japan and America. And it has an internal combustion engine under the bonnet, a very small high efficiency unit, and it doesn't drive the wheels. It operates from time to time to help provide recharging for the onboard battery, which powers the electric motor which drives the car. So it does away with the need for any corded recharging, and it recharges itself on the fly. It's a fascinating car to drive. Very popular. Toyota Prius, we're all familiar with Toyota Prius. This now outsells Prius in Japan. It's hugely successful in a very short period of time. Very elegant solution, and you will see this technology start to move into other models over time, and some of those components are also built in Dandenong South in Melbourne. So we're also proud of this project as well.
Does that engine run the same as typically a genset would, just 1 RPM, does it?
Yes, it goes to one engine speed, which is
so it's either running at that speed or off.
Absolutely, and it's an optimal speed which basically delivers what it needs to at the lowest possible speed, so it uses the least amount of fuel to do it.
What's the price range?
If you convert it to Japanese yen, it's around about early to mid 20,000.
Sorry, range, distance?
Oh, there isn't any in terms of it's a fuel powered car. Sorry, it's a.
Yeah, you've got a certain size tank.
You do, so driving range would be about 550. About 550.
So if you develop these for SUVs, like the petrol bigger vehicles like that, that would overcome this reluctance that people got, the range anxiety thing. Because conceivably they could take a fuel tank with them and have an infinite range.
In theory, yeah, absolutely, it could. When you start getting into the segmentation of cars and you look at the buyer profiles and what they want in 2017, not in the future, it starts to get a bit more complicated, and you can see the application of these technologies is originally confined to smaller cars where their effects can be felt more readily, but you'll see them moving into larger products as well. For example, we have a hybrid powered Nissan Pathfinder. That's a large SUV, and it's a 4-cylinder with a supercharger on it, so it's a conventional car, and it's got an electric motor to go with it as well. And that helps with town traffic, just getting around to CBD. But it's not intended to provide that extended range. You can start applying it, that's absolutely right. But when you start factoring in at this time the investments that go with it, you've got to keep in mind the business case for the car and what its ultimate retail price will be, which, as I mentioned before, in time will come down slowly. And that's why the evolution is a little bit slow, and why no one's yet come out with a full-sized off-roader with an electric motor in it, for example. It could be done in theory, but we're not there yet.
What's the price difference in Japan between that and the LEAF?
Oh, good question, actually. I cannot remember the LEAF price at the moment. I will get back to you, but it will be significantly cheaper than a LEAF.
Is there any chance of that coming to Australia?
Watch this space. I can't confirm anything for the benefit of the recording. The expansion of electrification is significant. You're going to see more changes in the next 5 to 10 years than you saw in the last 15 to 20. And I anticipate from other brands as well.
So we can see a value in the car is also having a charging port on the side for people who've got solar PV or whatever that can charge it essentially for free.
Yeah, absolutely. Mitsubishi does it with the plug-in hybrid that they've got an SUV. But this model doesn't. And again, I can't answer that specifically, but it might be a cost-related reason because of the intended audience for that car in Japan. It's target market. But you're right, it would be a benefit. And you've got to keep in mind the business case on everything.
Sure.
Just a question, just a query. With regards to manufacturing costs, this is totally excluding development costs. Let's say you're comparing your LEAF to a Polestar in production, because you're talking about a single size car. In terms of cost, straight material costs and labour costs, which is actually cheaper for me?
I wouldn't know. I wouldn't know.
Because in my mind, an electric car should ultimately be cheaper to make than an internal combustion engine. There's just less moving bits, there's less control required. So I'm just wondering, in reality, does it actually come out of the engine?
If you compared two cars side by side in isolation, you're absolutely right, and I agree with you, that would be true. If you look at the scale of the 94 odd million cars that went on the road last year, EVs comprise such a small percentage by comparison. So the scale effect and the per unit cost of those cars comes right down significantly, and that's why it's very difficult at this time. You can make those comparisons, but the true cost benefit that you're pointing to never gets a fair representation at this time, but it will as these types of cars, EV-related products and EVs themselves, because they bring the cost per unit of every component down as they grow up.
Surely must have a costing, a figure.
Absolutely, and it would never, and to be totally upfront, it would never be shared with me.
No.
That would be a tightly held fact inside the company because of the competitive nature of the business, as simple as that. But you're right, those numbers are known, but they're never made public, to be totally upfront. Good question though, good question. And it's true, there are fewer moving parts. If you look at the scheduled servicing on a first-gen Nissan LEAF on our website, it's significantly less than a Pulsar or a Hyundai i30 or a Toyota Corolla. It just simply is, you're totally right. This is how e-power works compared to a couple of other powertrain layouts. As you know, a battery electric car on the left is very simple to understand, and a conventional hybrid will see that piston engine driving the wheels from time to time. You've all driven a hybrid powered car at some stage? Yep. The transition between the two is pretty imperceptible, but you can just feel the vibration of the IC motor. We've simply used it to help produce the electrical power needed to keep the BEV going. But we just don't confine it to the cars we sell. We actually go racing with these cars, and I've got a few cool examples if you're into motorsport. This is a Nissan LEAF NISMO RC racing car. It looks more than just like a modified LEAF. It's rear-wheel drive, not front-wheel drive. Extremely fast, carbon composite structure, relocated engine for weight distribution, and has been a fabulous test bed to learn a lot about the technology that goes into future EV models. But this next car, if you do like car racing, is a standout. It's called the Z-Odd RC, and this raced at Le Mans in the 24 hours 3 years ago under what's called the Garage 56 program, which they allow the last garage in pit lane to be dedicated to a future technology, and they gave that to us, and this is the car we entered. This is the first car to ever do a battery-powered lap of Le Saf, and it went well in excess of 300 k's an hour to prove the technology against conventional technology. So in terms of test bed, tick, and in terms of marketing, big tick, because it turned a lot of cynics around in terms of their own commentary in the press around the funny-looking car that might not cut it actually was rather rapid and rather reliable. But last month we announced we're going to go racing in the FIA's Formula E series, which is a great series. It's growing. It's out of step with Formula One, so its season runs through the European winter. And it's a great place for us to send our Nissan Intelligent Mobility messaging and to get a lot more data. And if you're a motorsport fan, you will know that racing does improve the breed, especially in terms of materials, technology, processes, and how to make things very, very quickly. So that's a great, exciting development. This is the last thing I'll show you before I wrap up. This is a concept car we showed at the Tokyo Motor Show. It's called the IMx crossover. It's called a crossover. It's a common term in our industry because it crosses the best bits of a passenger car with the best bits of an SUV. So better packaging, wagon-like body, higher stance. This is a full 100% battery electric vehicle, and it's got two engines, 320 kilowatts and 700 newton meters of torque. And if you're familiar with those numbers, they are supercar level numbers, like Porsche 911 turbo numbers. They're very, very high. 600k cruising range. And this car is the indicator of where all of our intelligent mobility technology is going. So it's not just a show car. What you can see is a lot of where we are going, not just in terms of how it looks and what it has, but the type of cars that are scheduled not just by us, but probably by our competitors as well, which is a reflection of what the market wants. And as much as I wanted to show you an awful lot more about the future, I think this is a great indicator to show you that the future of EVs is very positive. They might be niche now, they might be unique and a discovery piece for plenty of people for years to come, but they've got a very solid, heavily invested future. And that's it. I hope I did 20 minutes, 25 minutes. I tried to compress everything in. I hope you found it informative. Thank you very much.
So, Pete, when's the crossover going to be on the mark?
I've got to turn off this microphone. Pete, we would love for a crossover version of the car to come on sale as soon as possible, but we don't know at this time, Pete.
Sure, we can't have it pre-ordered?
You're welcome to place an order, but I can't give you a delivery date. I should have brought an order pad. Please find my details on the screen, take a photograph and stay in touch with me. I'd love to hear from you.
When do you think this will stop releasing new petrol cars?
It's a very, very good question.
You don't have to, just
Just between us. Luckily in my job I get to see a lot of things with the media, and this question comes up a lot, and a lot of automakers give different answers, but there are some commonalities to those answers, and they are that fossil fuel powered vehicles will be around for some time yet, because we anticipate a tapering effect, not a step change. But you will see an awful lot more battery electric vehicles and battery electric vehicle related models coming out during that phase. You'll see them cross over at some point, but it's very difficult to anticipate when that would be. You'll get a reply from the oil companies, and you'll get a reply from 48 different car companies. It's very difficult to anticipate.
You don't think there'll be a major step change when the prices become almost the same? So I feel there will be a massive jump.
From everything I've read and I've been exposed to, I don't think step change, but I think the biggest change could possibly occur at that time, where the uptake could take a shift. It wouldn't be a radical drop of fossil fuel powered cars and a huge uptake of BEVs. I hope they would be, but I think on the current rate of uptake, it would be a significant shift, but not a huge shift. But its trajectory will keep on going, if that makes sense. Price parity is another topic that's very related to what you just asked. People ask, when will electric cars become similar in price to a conventional car? And the current consensus is around mid-2020s, second half of the 2020s at the moment. That's based on what we currently know.
Is that just based on volume?
More things than that. This is the
battery technology
intersection of various factors. Because of the competitive nature of the industry, and I know I've said that a number of times, but I promise you it is intensely competitive. No one is lazy. Batteries will become more efficient. They're bound to become smaller. You can fit more cells and get more density and higher range from the same amount of mass. Prices will come down as the uptake increases. As governments become more progressive in terms of their view of the uptake for their electorates, they'll put in incentives. We just know this will happen because it's the path that's been trodden for the last 7 years. Long game.
I wonder if Nissan's planning to put in any charging stations around Australia.
No plans at the moment, but it's been a constant topic for some time. We've talked to a lot of organisations, including governments, about this. And you're obviously asking in the context of Tesla doing what they've been doing with their supercharger network. We don't have those plans at the moment, but it doesn't mean that we wouldn't have them in the future.
And what sort of system of charging are you likely to use, and do you think there'll be a standard in the near future?
You mean for Nissan, or you mean the industry as a total?
The industry.
It's a very good question. If you didn't hear it, is will there in the future be a standardised charging system? If you cast your mind back to, say, the late 1990s, you'd like to think that that would have been the case, given the runway of time we had to get this organised. But then everybody started to, not everybody, but certain companies had different desires, and they had a high-performing battery, and they needed a different type of plug and lead, and it gave rise to different charging types. We hope it will in time. But at the moment, the scale of recharging networks in places like Japan are quite extensive. So changing them would now take a bit of time. So if it was to occur, I think it will be in the long-term future to have a single type charge point for standard, slow and for rapid charging. It would make sense, wouldn't it, to have one thing?
Does Nissan look at how they can produce the energy, and with electric vehicles, the most cost effective is to produce your own energy in your home? So do they go and start looking at that market? Because I know a lot of the engineers don't want you to touch the battery sort of thing for good reasons. But is there looking at your earlier slide, looking at what that car can do, plus more, is really looking at how do they integrate power into the home, and how do they coexist?
Very good question.
Is there anything they can share on? Do they look at that, or?
Yes is the answer. And there has been the emergence in the last few years of that occurring. So if you consider the energy chain going backwards from the car using it to move through to it being stored in the car, it coming from somewhere, it being stored from somewhere, it being generated, Nissan is considering the steps that precede the car itself. And a couple of good examples are vehicle-to-home and vehicle-to-grid technologies, where a company such as Eaton, E-A-T-O-N, in the UK, for example, you can buy what is the equivalent of a Tesla Powerwall for your home, and you can store your energy and deploy it in your car as needed, and then when it returns with a surplus, you can go back in and help power your home. And yes, it is the answer. But the complexity of doing that is another level of complexity next to the car, but it's a necessary step to be considered, of course, isn't it? Because it's got to be more than just the car, and it's a big part of our intelligent integration plans.
So you're saying that the car can export power, does that complicate the weight for inverters and export?
On board the car?
Yeah.
That I don't know, because I don't know what the situation would have been had that capacity never been there, because I wasn't part of the development process. But it's a very good question. It's a very good question.
The other question I had was, as energy storage, we're using batteries. Are there any capacitors that you've heard, or hybrids between batteries and capacitors being used?
No. But I'm going to ask the question in turn that you've asked. Good question. Please take a photo of my contact details. Thank you.
I'm thinking that an electric car might have a longer working life than an IC car. That's one question. The other one is recycling of components at the end of life, like different batteries. Any information on that? I've heard some criticism that lithium-ion batteries are a bit of a mess at the end of their life.
Almost all of the LEAF is recyclable at the end of its working life. But of course, for that to occur, you need an ecosystem of recycling for it to occur, and a place like Japan is perfect for that. If you've ever visited Japan? If you've ever had rubbish in your hand and tried to find a bin? Yeah, that's me every time. It's very difficult to find such a beautifully clean place that's so orderly and organised with refuse, and how you cut that up in terms of ensuring recyclability. So in a place like Japan, absolutely. Outside of that, I can't speak for it, but most of the car is designed to be recycled. In fact, part of the upholstery, for example, in the car is made from recycled denim cloth from jeans. A lot of the recycling is already in the car before it goes into its next life cycle. What was the second part of your question as well? Sorry, I missed.
Oh, the battery, parts of the battery be reused. Well, I've heard it said that there's an iron battery at the end of its life is a chemical mess, whatever that means.
I don't think, it's a very good point, I don't think there's any motive technology that is purely 100% clean except for wind on a yacht. And I'm not being silly there, that is just the truth. And so that known, a lot of the battery stack systems that have been used in LEAF have gone on to do other things, such as power football stadiums for their lighting systems at night time, and to power buildings when they've been taken out of the car, when the car has either been crashed irreparably or is at the end of its working life. But compared to an IC car, which was the first part of your question I now recall, it's a very good question about what is the working life, declared working life of an internal combustion car. It's very difficult, I think, and I could be wrong here, to estimate that, because they're now just so good. Because we've been making the same thing for so long, it's to pull the cylinder head off a car is a rarity these days. It would be 300,000-400,000 kilometres before that might occur. And if anyone disagrees, you're welcome to disagree, but it's a rarity to see that occur. And then in the buying cycle of consumer behaviour, no one seems to own a car for 400,000 kilometres anymore. I mean, my dad's old XY Falcon station wagon might have got there, but today, under the leasing arrangements and financing arrangements for cars, most cars are owned for 2 to 4 years, and they go into the secondary market for another 5 to 6 years, and they might get a third owner. And they just tend to fall off the road in some respects, don't they? You don't see many cars en masse from the 1970s or 80s anymore, which in many respects is a good thing. So it's very difficult to compare it, actually. It's a good question, though. You guys have great questions, I must say. This is unlike any press conference I've ever been to. Fantastic.
We're way more intelligent.
I can't comment on that for the recording. What's the next question?
In the last photo of an IMx car that you said had 2 engines.
Yes.
The question is, how many driven wheels?
4.
so it is an all-wheel drive vehicle.
Yes.
Okay, I have a second question as well,
Mm-hmm.
and that relates to a question asked down here about charging of cars. You said through Japan there's a extensive charging network. Is that for Nissan only, or is that for all electric vehicles? And I would be greatly surprised if some executives in Nissan didn't talk to their counterparts in other EV car companies. And is there any reason why they shouldn't get together to talk about the uniformity of charging?
That's a beautiful question. Now the gist will be correct, but the absolute numbers might be incorrect. But this will give you the rough answer. I think it's an extraordinary number. It's either like 67% or 56% of the world's fast chargers are sitting in Japan. And they came about by a combination of, this is generally correct, it was 3 automakers, 2 power companies and 3 banks, or 2 banks came together. That's an extraordinary collaboration to establish it. So it's definitely collaborative, and yes, it can be used by different car makers. Because it's the long-term view of the investment. It's almost as if a former executive, a very senior executive worked at Nissan, was asked about Tesla, and he said, I think it's a good thing, of course. Anyone who can advance the EV cause is doing a good thing. And I share that view personally. They're contributing to a change that is going to happen. Let's just have it happen sooner. It's going to happen. BEVs will become far more widespread than people anticipate.
Just as supplementary to that as well, within the last year I was in Norway, and I was impressed to see almost every city I went to in Norway had charging stations publicly accessible, parking spots marked just for EV vehicles with curbside chargers.
Norway's one of our most successful markets around the world.
If they can do it, we can do it.
Absolutely, I share that view.
I just wanted to make a quick statement and then ask a question, but just in relation to people talking about the longevity of vehicles. People often mistake the longevity of the vehicle that it surrounds nothing more than the engine. Well, that's actually not true. The door hinges wear out, the UVs get to the seats, the electrical switches start to play up, the door seals fail. There's lots and lots of little things, and if enough of them occur at once, that vehicle is declared it's out of service. That's the reality. And that seems to be taking about 10 to 12 years or 350, 400,000 K in a lot of cases, and that's not really changing, in my observation.
I don't have any data on that. It's a very good question.
And I think that's probably determining the length of time that a vehicle stays in service. And what's more, 10 or 12 years later, technology's on the change and people tend to trade up and let's get the service life of the product.
That buying behaviour, I totally agree with that. I don't have any data though in terms of failure rates of a componentry that is smaller. I mean, to have a major failure, engine transmission, versus the power window switches stop working. Everything has a failure mode built into it, from aircraft to vacuum cleaners. So when that occurs, I can't speak to that. But here's an interesting thing to ponder when you're an EV maker. In car making, there's a thing called NVH, noise, vibration, harshness. It's a very important part of the engineering of a vehicle because it determines so many things, the human experience of the vehicle and whether it's positive or not, through to the simple fact that heat and vibration, the 2 major enemies of any machine, and how they're managed. So if you've got a vehicle and the only thing you can hear at any speed is the tyres contacting the road and the wind running over it, it needs to be well built because there's no primary and secondary out of balance forces being managed and there's no pop of the exhaust, etc. So there are no masking effects. So the challenge of EV building for any car maker is much more difficult, and that speaks directly to what you just said.
Well, in regards to NVH, in the late 90s, a Mitsubishi Magna was considered an extraordinarily quiet car city. Now, it's old hat, it's noisy, so the technology moves on.
It does.
My question, which is on a different note, I was wanting to know whether any of the EV companies are doing any research as to market acceptance across the board of this technology throughout different countries.
Yes.
Because I would imagine, and I'm only shooting from the hip here, the acceptance of this sort of new technology is far better in the likes of Europe than it is in Australia. Has there been any measuring done on this one?
Yes, to both of your questions. Yes, that research I can tell you the research before you go to market is quite extensive, and when you're in the market it's equally extensive, and it just keeps going because it changes over time. And I think the perception of EVs in Europe would be different to that of Australia without consulting anything, because the numbers bear that. They absolutely bear it. Same with Japan, same with North America. In those parts where, say, California, where for some time now there have been reasons to buy an EV, absolutely. But cultural factors change, and they change slowly. And when you're an automaker, you sometimes want them to change much faster, but they change. And it's changing in the right direction. Sorry, the question, sir.
We've been talking about longevity. How long does a battery in a LEAF, for example, last? And is it measured in terms of cycles? And what's the experience been since 2012 here in Australia? And what sort of depletion do they experience over, say, 5 years?
I have a lot of questions. The first thing is the car has only been in market in totality for 7 years.
Yeah.
So to have a long view of in-market performance, it's still quite young. We've had no catastrophic failures.
Yeah.
That's one first fact. In places of extreme hot and extreme cold, you can see depletion rates increase, but the company has a warranty scheme that if your LEAF battery goes under so many bars or lights on the dashboard, it will be addressed. And we've not had any of those experiences to my knowledge in Australia. Considering though, we've only put 636 on the road, you would think that Australia's summer conditions, for example, would test it, whether it was 60,000 or 600, but we haven't. It's a very young technology to be in the markets. It's hard to get longitudinal data in that respect. You can see how everything from metallurgy and pistons and what are ideal and so forth has been around for so long, but it's hard to speak to that. It's very hard to speak to that. Yes.
Do you have any data on the long-term owner costs incorporating fuel use and servicing?
Yes, we do in theory. I didn't bring any with me at the moment, but you can imagine the first buying group of LEAF, they are, in one word, ambassadorial. They want the car, and they share voluntarily a lot of data with us without us even asking them. We've had a lot of that come our way, and it's surprising how inexpensive the car has been. Like, it's below half you would see for an equivalent IC car. And talking to the point about NVH and the quality of the build of the car is exceptionally well built. It's built in Japan, it's built in North America, and it's built in the UK. Australian cars were sourced from Japan. Warranty rates, not that I could quote them, anecdotally are extremely low, and the running costs are very low as well. And if you go to car sales today, I look at car sales because I'm a car person, you'll see one LEAF for sale. They very rarely come on the market. I guess if you've looked at it previously, you'll notice the same thing. The most of percent is 3 at any one time. Need more time in market.
Nissan America seems to be looking after all the LEAF buyers with upgrade battery packs. Is that the same case in Australia?
I've not heard of it happening here. Mind you, we've only...
Just to get some consumer confidence in, so people who want to buy second-hand LEAFs or can't afford $45,000 car and buy a $20,000 LEAF, hold a LEAF and upgrade the battery pack.
That's a good question. I guess we haven't enjoyed any scale effects like North America has had to actually enact that. But keep in mind that only the first generation of LEAF was sold in Australia, the 2012 model, 24 kilowatt hour battery, for example. That was upgraded over time from model year 13 onwards. We didn't sell that simply because the car that we imported was homologated or certified to be imported as a full volume car in Australia like any other full volume car. And to bring in successive model years requires additional expense to do it. So, totally open with all of you, from a business case perspective, we decided to stay with the model that we actually had. So if any car was going to feel that effect, it would have been the earliest first gen car, and we haven't had that. It's quite interesting.
Following on from that question, and your 636 car sales over, my understanding was for most of that time, none of the dealers knew anything about them if you spoke to them. Most dealers didn't have a test car, people would walk in and take a test drive. That was what I heard anecdotally.
That would
be different in the future with the next model.
That doesn't surprise because of the 192 dealers, we've got only a handful of LEAF dealers. Yeah. So most Nissan dealers aren't appointed LEAF dealers. Yeah. If you went to a LEAF certified dealer, and the reason there are specific, say, LEAF or Nissan GTR dealers is because there's a significant expense in being one, and that's everything from training to special tooling. to be able to fix the car. If that happened, it's often a function of, and I'm being totally upfront, is movement within a sales team. That a sales consultant, for example, who would know the car in depth, left to go to another business, and a new person who replaced them wouldn't know it at that time. But if you ever want to know anything and you were never satisfied, you just call Nissan. It's 1-800-035-035. Just call and someone will help you. But that doesn't surprise me. It's an unfortunate part of the car industry and retailing, is that staff move and knowledge moves. It can sometimes take time, but no disputes from me.
Do we have a measure for the economy of an electric vehicle? Like, is it kilowatt hours per 100 kilometres or something like that?
Yeah, the Green Vehicle Guide has one that is used. It's only for 3 car makers. Openly, I can't remember what it is. The Green Vehicle Guide has one. Normally, when you certify a car, you build what's called a road vehicle descriptor, and it allows every registration authority in the country to register that car. And it has particular data, but EVs, as you can imagine, don't fulfil a lot of those boxes. So other bodies have come up with those answers. So it's a very difficult question to answer, because the universal standard for a car is litres per 100 or miles per gallon. But a lot of different bodies have different views about how an EV is calculated. So there's no one universal that I'm aware of.
Just looking at the figures published, it looks as if 20 kilowatt hours per 100 kilometres is pretty well achievable now.
Yeah, pretty much.
And I wonder what the target is in a domestic vehicle.
Oh, I don't know what the target would be, because again, it's part of the development nature of car makers, but it would be beyond what is achievable every time, because the engineering target set for any product in the automotive industry, whether it's crash safety, longevity of a door hinge, fuel economy, is always a stretch. I can promise you there's never any comfort in there to do it, because there's significant money and time available to build it, and they will go after it. So that approximate equation you give, I agree with, but you'll see that improve significantly in the next 5 years. Significant investments are going into battery development, not just in auto, you'll notice that. Some major buyouts and investments are going into battery tech.
People have been talking about a crossover between electric vehicles and petrol cars. People give any thought to, when there are more and more electric vehicles, suddenly petrol stations will be closing down, and there will be a sudden drop, because at the moment the question is, where can you charge an electric vehicle? But at some stage in the future, where can I find petrol for my car?
That's a valid point. That time will come, and I do think the oil companies and the distributors of fuel will anticipate that movement coming. You can forecast this. Did I hear maybe? You know what, I don't discount that. But because of the scale and the data available, it'd be reasonable to think that they could anticipate that time to within a 5-year period. We're always following... I can't vouch for the film or camera industry, but there is so much data, long-standing data, that you can analyse that tells you roughly what might happen. The hardest parts are the human factors, consumer behaviour. That's one of the hardest things to do, is to anticipate what people want. But you can, in hindsight's perfect, you can see car buying in this country went largely, this is broadly speaking, largely from E-segment, large car, Falcon, Commodore. People started buying equivalent sized SUVs, then they started buying smaller versions of those SUVs, and here we are today. And that's where they've moved from. Could you have anticipated that? I think you could have, towards the plot points of the story, you could have. Which tells me that in the selling of one product, through one channel, through one method, says to me you should be able to anticipate that. I'm oversimplifying it, I must admit, but there are 67 automotive brands in this country. There's 400 different new cars you can buy. And that's how competitive it is in Australia. It's crazy, is the best way I can describe it. In America, they'll sell 18 times the number of cars we will, and they've got almost half as many brands. So for the fuel industry, I think, should be able to anticipate that. They're very smart and they'll have a lot of data, but that time will probably come.
Are we liable to see options for battery sizes in cars?
Oh, that's a very good question. I imagine so. Because you can get options for engine size in a car, entry level, mid-spec, high performance, and people will want different things. So yeah, I anticipate that might happen. I'm not speaking for Nissan there because I don't know that, but I think it will come. I think it will come.
Tesla has different battery
Performance levels, yeah, absolutely. But I think if you think of the broad spectrum of mini city car through to ultra high performance sports car, those consumer tastes won't change, but you've got to meet them, and that's why I think that will come. And that's a very big spectrum. I'm talking high economy, 100 kilowatt output, to extremely high performance, like 400 kilowatt output. Like they're vastly different types of buyer and products.
You know, to talk to the commercial range, small trucks, utilities, delivery vans, even large trucks.
Tremendous opportunity in that space, and that's why, of course, Renault and Nissan are both in there. At the moment, those mid-sized to small commercial vans are the perfect place to put an EV arrangement. They don't have the mass and they don't have the carrying capacity to deplete them rapidly, and they are perfectly suited for back-to-base operations in any metropolitan area. If you're a delivery company, a courier, Australia Post, for example, would be a perfect home for a vehicle like that. And I think you'll see that will be possibly one of the fastest emerging sectors in EV around the world, because it's a business. It needs to be reliable and dependable. It needs to be cost effective. It's all those things and more. And it's conventional. It feels, smells, operates just like any other small van, but it's an EV. So yeah, I think you'll see a lot of good things in that space.
Trucking?
It will emerge eventually. I know, and I read that Tesla is looking to develop a semi-trailer to put on sale. I read stories of truck-only lanes heading down towards the, I forget the name of it, Pete, the port down the Geelong side. Starts with L. I can't remember it. Can someone remind me? Not Laverton. There's a port development down to past Point Cook, down towards that side of the bay. And building roads and having prototype self-driving electric trucks, I've read this several times, as one potential project to move goods into the state and around the city, reliably and quietly at night time. I think there's great scope for that. It tends. I think the path that EV will follow will not be too dissimilar to what IC cars did, especially in the post-war period, in terms of not just consumer taste, but what was built. And I think EVs will apply to those segments first. And then those technologies that will go on top of them, such as autonomous driving, will sort of make it a bit easier, but they will still resemble the cars we've always known. And that's why I think trucks will be a place for EVs as well.
It's not like a river.
No, I can't remember the name of it. I'll have to think of it. It's bugging me now. Port. No. Sounds like 2 words.
With the the subsidies on electric vehicles, and maybe that doesn't happen, but over in Europe they had real good success with the registration being linked to the CO2 emission. And really changing how people buy, and really speeding up that process without sort of giving subsidies. And do you guys agree with that? Or
yes, at all 3 levels of government in Australia, you can make a difference, and I agree with you. It has made a very big difference. Depends on the country you cite. For example, in Denmark, it's relatively very expensive to own a car. Yet they're effectively tax-free in that country, so the uptake of EVs is very strong because they become very affordable. But at a federal level, you could have tax-based incentives. At a state level, it could be free registration. At a local level, it could be free parking. There are so many things you could do that combined make it such a compelling reason to choose one or just to consider one. But at a state level, I think the ACT is the only state or territory that currently has a low emissions subsidy. We're talking not a lot of money, and principally it's a good thing. We applaud anyone who takes a stance on that. But its magnitude is tiny in comparison to, say, a Denmark. So its effect on someone to consider it becomes equally diminished. But it's the right step, it's the right direction, absolutely. And I must emphasise, even our global chairman, Carlos Ghosn, I don't know if you know his name, even he has said publicly, it's to kickstart it, it's not necessarily forever. These incentive-based ideas at any level are enough to get it started. It's basically turning the propeller on a plane, and once it's running, you don't have to keep turning it. And that's the scenario we're working to.
The solid-oxide fuel cell, bioethanol, is a clever solution to range problem for South America where bioethanol is
widespread.
Is there going to be another development more tailored towards solving that range problem in other areas of the world? Can that reform or work on other?
I imagine so, and I believe those sorts of developments are underway. I'm not privy to them, but I was very fortunate 2 years ago to go to a small discovery tour for that variable compression engine I mentioned earlier, and to meet the engineers who worked on it for 19 years, and that's sometimes how long it can take to develop these things. And Harry Ricardo in the 1920s was coming up with this stuff. You know, you put a swash plate in the bottom of a crank and you push it up. You can do all these things, but to get them to mass production so they perform exactly as a consumer expects takes time, and that's why I think those developments are actually occurring.
So Nissan continue to look at fuel cell technology.
Absolutely. As I mentioned, I shouldn't say everyone, but a multitude of car makers are taking an in parallel variety approach to solving to getting to zero emissions. And I'll be straight up here. If you take a gamble, which is a word you'll never hear in our industry because it's very conservative because there's a lot at stake. If you go, we're just going to build battery electric vehicles, which is a very noble thing that Tesla has done. It's a very noble thing that Volvo has claimed will do by a certain period. It has consequences. What if people don't buy your cars because they don't want BEV just yet? It's a risky thing to do. So everybody has a variety of solutions. You know, fuel cells, such as what Hyundai is doing, battery electric, plug-in hybrid, and so forth. Partnering diesel with electric, petrol with electric, and over time will inch their way towards a ZE answer. And that's effectively the strategy everyone's using.
So the second question about battery technology. Are all the OEMs buying their own battery companies and embroiled in a sort of arms race, where they made their own engines before, or is it more like they're buying an off-the-shelf battery?
Mix of both. You might have read Nissan recently sold its own battery company to GSR in China, an investment firm, and that transaction will complete in 2020. And the reason for doing that is to become more cost competitive in the development of battery technology. But arms race is a very good description. It is that competitive, and you'll see this inching up of performance. In terms of whether it's NEC or Samsung, this has been going on for a long time, and they are deeply competitive companies. So yes, they are in deep competition, and that means as consumers, everybody benefits because the commercial gains for everybody are significant, absolutely significant. So no one's passively waiting for an answer; everyone is pushing to find an answer. Oh, just the gentleman behind you. Sorry, he's not earlier. Sorry.
From a consumer confidence point of view, and the transition, why is there such a lack of plug-in hybrid electric vehicles in Australia?
I don't know.
Why don't you have one?
I'd say expense.
Because they've gone from one extreme to the other, and it hasn't been this transition. And you don't get people following on those little steps. You've got to make a big leap on range anxiety, or not.
Well, I like to think we have. You've got to start somewhere. We started in 2010 as a business, and other car makers have started. And from that point, as challenging and as expensive as that first step is, incremental gains will come. But always keep in mind in the background, Nissan sells conventional cars like the 67 other auto brands in the country, because there has to be commercial success to underpin the development of these technologies. So we have to keep succeeding in the sales race with our own SUVs and crossovers and passenger cars in order to fuel this. And that's, in very short terms, the reason why. Plus expense. Changing the cost of a car in the smallest way can make a very big difference even at the per month repayment level for a consumer, especially in a fleet arrangement which is a large proportion of new car sales in Australia. And it's often nicknamed a user-chooser system, where you work for a business and they let you choose a car from a certain range. And you can price yourself out of that range by adding certain things to it.
Do you think that the biggest problem in Australia is consumer confidence with regards to the LEAF?
I think it's an intersection of several factors. The consumer confidence there is probably based around the notion of range anxiety, which often goes with every EV report. I think if you read car reviews in North America or in Japan that have been translated, range anxiety rarely ever comes up in the 300 words of an editorial copy, but you'll hear it here all the time. So that's the first thing underpinning it. I think then people, when they investigate, think, oh, well, there isn't an extensive recharging network like there is in those other parts of the world. That's the next thing.
But don't you think a fair would help that consumer confidence?
A FEV?
Yeah.
A fuel cell electric vehicle?
No, a plug-in hybrid electric car is a transition. People will discover that I don't need to put fuel in the car.
Yeah,
It takes time for people to learn that and understand that. I mean, you look at I look at LEAF forums all the time. You look at LEAFs who are down to 70k range now because the batteries are degraded a little bit, and they're happy with it. They had the range anxiety. They've lived with the car 5 years, and they're so happy with it.
Well, most Western consumers commute 60 kilometres on average, and that's the average. That's not the median, that's the average. So that's got the high stuff pulling that number up. But to answer your question, yeah, I do think it would help, but it does come down to expense. We could put a cord into, and I'm simplifying here, the e-powered Nissan No, but that might price it out of its segment, because you've got to remember too, keep in mind, where you go from one size of car to the next, there is a greying area here where you're buying the top of the range of one thing and then the entry range of the next. And that may sound hugely simplified, but it is true. Not many people will play here. They'll buy here and they'll buy here. And you can price yourself out into sales volumes where it doesn't succeed to the degree you needed it to. So you've got to factor everything in. And you can counter that by taking things out of the car, hypothetically. Let's remove this feature or that feature. And then you alienate the middle part of that buying group again, and you sell less again. It is a tremendous balancing act. Product planning has taught me. It's very, very challenging. I ask the questions myself internally. Why don't we this? Why don't we that? And there's always a reason, because most of these people are 80 times smarter than me, and they would have thought of the answer ahead of time.
So if I bring the Ioniq plug-in hybrid here, is Nissan going to try to counter that?
Possibly. We weigh it up. If we had a suitable product to consider it, if there was a business case, if that business case was underpinned by a business opportunity, a sales group who would buy it, we'd consider it for sure, like we do with every model, whether it's an LCV, a heavy commercial vehicle, or a car. Absolutely. Just mindful of time, we have to vacate the building at 8.
So, I'm not sure if this is exactly the question, but I just wanted to comment on what you said about predicting markets and predicting what people want. A lot of the market we have occurred as a result of the California Clean Air Act.
That's right.
Where it brought in higher standards of efficiency, and in so doing created a loophole for the slightly larger vehicles, such as the Ford Bronco, at which point auto manufacturers realised that they could make a massive profit. Instead of selling $30,000 or $15,000 cars, they could sell a cheap car to make with a much higher profit margin, sell it as a freedom machine to men and a safety machine to women, and it was the perfect storm. Now there was no long-term planning for that. They hit gold, and the market took off, and all the car manufacturers around the world jumped on that train and have been making a fortune ever since. And since then they've started to downsize because those original cars were flipping on freeways and fairly clunky and became unpopular with women. And now, is there a responsibility of investing some of that massive profits that they've been making in the transition to cleaner electric vehicles, or do we use, is there some way of using an analogy to bring forward EVs? I don't know, but there's been a lot of money made off the back of that pollution, and now we have that inertia in the market of distorted perception of what vehicles should be, because we thought that they were going to efficient vehicles.
The forces applied to the industry that develop the products that we ultimately buy come from a few different places, and one of them is regulatory. One of the best examples is a move towards a new emission standard that is 95 grams of CO2 per kilometre travelled. And in very brief terms, it's a very challenging target to meet with a fleet. This is the reason why you're seeing downsizing of engines, single and twin turbo charging to make them more efficient, etc., etc. CVT transmissions versus step transmissions, two-wheel drive versions of SUVs that didn't exist, and so forth. On it goes. But you will see that there are limits to what you can do with what you have. So there are shifts in the core products that are being made, and at the extreme end of that is battery electric vehicles. The forces that are being applied, whether they're regulatory or market-based, are all going in the same direction. And as a consequence, you'll see the Southern Hemisphere, where we import cars here, will benefit from that. But the expense of doing it has to be paid for from somewhere, and that's where you'll see that a lot of those monies, regardless of where they come from, get reinvested.
But there's a disincentive for car auto manufacturers to transition to this because the existing business model they have is highly profitable and predictable, and they're going to something which is less profitable and less predictable. And there's a lot of tax subsidies which are invested in the model of supplying fuel to ICE engines. So,
at the current rate, it won't be like that forever. It just can't be. It just can't be. And that's the tapering effect. You're right. People buy high capacity engines because it appeals to masculinity, and car makers, like any commercial entity, will exploit that because they have a responsibility to shareholders and investors. They're trying to make as much money as possible, and openly there's no shame in that. That's what commercial enterprises do.
Yeah.
But in parallel, a lot is going on, and this is a very big shift, I must emphasise. This isn't business as usual for the auto industry, especially in the last 60 to 70 years. So this is the intersecting time when things will change, and a lot of those profits are going into huge investments. Consider the very upper end of the car industry, the elite end, like Aston Martin, for example. Aston Martin makes effectively two cars powered by a V8 and a V12 engine. How are you going to make an EU7 hypothetically compatible V12 engine? Who's going to make it? It's very difficult to do it. I think in the end, probably Volkswagen Group or Ferrari might be able to do it. They're now using Daimler's engines because they've been able to invest in high efficiency technologies that can be applied to the biggest of their motors, because there is, as niche as it is, you can see the constraints being applied, even at the top end of town, so to speak, and they're being applied everywhere, whether it's the market saying, I want something cleaner, I don't want that anymore. And that group is growing, and there are regulatory forces saying it's good for our community to have cleaner air.
And does your company advocate or push government to bring forth those stricter laws?
We can, in short, yes, because we consult with them regularly at all levels in all countries, even Australia. We sit on working groups for CO2 output with the Federal Chamber of Automotive Industries, with the federal government, and we say to everyone, look, this is where it's going at a global level from industry, and car makers do it independently. Hyundai's there, BMW's there, we're there, and we have a similar story to tell because it's just going in that direction. And we lobby them, and I'm being upfront here, saying we need a context that suits this, because it's not just good for us, it's good for everyone who buys them, because the spin-on effects are positive, because effectively the rest of the world isn't making those cars that don't fit our regulations. Simple as that.
The demographic of this rising population that you're talking about, what demographic are they, and have you had successful strategies in influencing?
It's a very good question. A sample of 636 won't tell you enough in Australia, but on a global level, at about 0.3 of a million, you start to learn an awful lot. They're not too dissimilar to normal car buyers, or buyers of standard cars, I should say. They're not too dissimilar.
Let's change the word demographic to value driven. Are they more consciously driven from caring about the planet versus security driven for cost versus maintenance and all of that?
Without going into inferential statistics, the short answer is yes. They haven't
influencing them, and how?
Say that again.
And have you been successful in influencing that value preference, and how specifically?
I don't know if I can answer the last question, but I just think providing a product that speaks to that important value they have, that they put up the top of their purchase consideration set, I think answers it.
Do you have any modelling of how you think that particular value preference target market is going to grow?
At a global level, we would. I don't think at a local level. I can ask for that. But I assume we would. But I don't know if I'd say it. Very interesting. Market research is a fascinating area, and a lot rides on it. So you just can't do token elements of it. You need to find the bedrock under the water table, and you need to make decisions based on that, because for the lead times and the money, there's a lot at stake.
I'm unclear about servicing, like for a conventional car it can be 10,000 k's, but what's the servicing sort of interval, yes, for these cars, like a LEAF, I mean?
But by mileage as well, by kilometres. We have a thing called My Service Certainty. Most car makers have a similar thing. You can look on the nissan.com.au website and it will tell you the menu of what every service will cost per every interval. It's every 10 or 15,000.
It's about 10,000 k's, like in a conventional conventional car?
10 to 15,000 from memory, but the prices are a lot less. So when instead of paying $295 or $345, you're paying $125, for example. It's an awful lot less because there's a lot less in the car. One last question, and we do have to wrap up. It is at 8 o'clock.
Thank you. Apologies, I was a bit late to man cover this, but I kind of find it surprising that they're still talking about range anxiety. Kind of think that's been and gone. And the other thing is, when you look at Tesla and the Model 3 and the amount of pent-up demand, that must give massively strong signals to all other manufacturers that there is a huge demand. We're talking about consumer habits. I mean, to have a product that no one's touched, no one's seen, and to have, probably over 500,000 people put down money on it. What's that got to say to other manufacturers, and what's coming out of that?
There's a market, and a strong one, who wants it. Even if half those people never bought the car, that's still 250,000 people.
They'll sell on their reservation to someone else at profit.
I've heard that happening at times, but it says that there is a market who wants these cars. And if you take away the cult of personality of Elon Musk from it, and all that brings, and the fascination of a guy going to the moon, to Mars, building cars, it simply says there's a strong market there. People want these vehicles, beautifully styled, full of good performance and great technology. People will buy it, absolutely, that we know. And in terms of range anxiety, I share your view. I read about range anxiety and I think, why is it still 2009? I don't understand this.
I mean, BZD's done research to show that, when you talk about an average of 60, but you guys can probably prove me wrong, but in Australia, from people living in an urban environment, it's around 30. So this whole notion of range anxiety is just a nonsense.
We come at it from an angle, just to answer the first part, that you buy a vehicle that serves your needs. It's as simple as that. If you are a young family, you buy typically a suitable car for a young family that can take a pram and a child seat. If you're single and want to buy a third car, you buy a sports convertible or something similar. If you drive 500 kilometres one way to work, you typically wouldn't buy an EV, for example. You'd buy something suitable. It's very simple, isn't it? That's the view I take. And we encourage buyers to do just that. Because the last thing you want is a customer buying something they don't want. It makes no sense. So, yes, I agree with you. Range anxiety is very out of date in my mind, especially in places like Japan, Europe and North America. And hopefully it becomes out of date here very quickly. Thanks, everyone.
Well, it was a fascinating discussion. Would you please thank Peter? I'm sure some of you will have some further questions, and if we could take them down to the pub instead of asking them here, we really would like to try and clear this theatre by 8 o'clock. BZD's work is all supported by donations from monthly supporters, and if you value the work and you'd like to contribute to BZD, we'd be very happy to talk to you. You can catch up with the discussion group YouTube recordings, which Roger is making, at the BZD website, bzd.org.au/events/. There will not be a discussion group in December. We're having an annual general meeting on the Tuesday, the 5th of December. It'll be held at the Edinburgh Gardens Conference Centre in North Fitzroy. It's not just a annual general meeting, it's a quite extraordinary presentation. There's a guest speaker who will be Dr. Yasmina Dikisi, who's the Net Zero Program Strategy Manager at Monash University. Monash University is making some extraordinary steps towards sustainability. There'll be a live band, and catering will be supplied by the Asylum Seeker Resource Centre social enterprise. So please buy your tickets at the BZD website. This coming Wednesday, the ATA is having Michael Lord, BZD's Manager of Research, talk about rethinking cement. For anyone that's missed that, it'll be at RMIT Building 80 in Swanston Street on the 4th floor this Wednesday at 7 p.m. Thank you everyone for supporting the BZD discussion groups this year, and we hope to see you at the December dinner to celebrate. Thank you very much.